Hey guys, I'm here to do lesson 6.13 with you. Your learning target for today's lesson is I will be able to factor expressions. So your think about it says, the model below represents the expression 2a plus 2b. Write two other expressions that represent this model. One of the expressions should involve the distributive property. Explain how you came up with each. Go ahead and pause the video and work on the think about it on your own. Alright guys, so we have to write two other expressions to help represent this model. So I'm actually going to give you three different possibilities that maybe you came up with. So the first possibility is maybe you said, well, this is one group and this is another group. So we have a group of A plus B, and then we add that to another group of A plus B. Okay, and we're doing this because we're combining these. So these are combining. A plus B plus A plus B, just like in the model. They're also using a grouped sum. So every time they're putting A plus B, they're using them in parentheses. Another option that we have, number 2, is, well, if I notice over here, I have the one group and then two groups. Okay, I know that repeated addition is also multiplication, so I can also do 2 times the group size, so the group being A plus B. Okay, so in this expression, we're showing two groups of A plus B. We're also showing that we know that repeated addition is multiplication. So instead of adding it twice, we multiplied by 2. Finally, we can have a third option where we have 2a plus 2b. So here, I've applied the distributive property. If I come back to expression number 2 and I distribute that 2 across the sum, I end up with getting 2a plus 2b. So I know that 2 is a common factor of both terms. Because if you notice, A has a 2 and B has a 2. Okay? So before we go any further, I do want to define what it means to factor out. So factor out means to do the opposite of the distributive property. So the distributive property, you're supposed to multiply, right? I take this 2 and I multiply it by both terms. So I get 2a and 2b. Okay, but for factoring something out, instead of multiplying, you're going to be dividing. So we'll divide both terms by a common factor, which is why I pointed out the common factor of 2 on our third expression, where they both have 2 in each term. So let's go ahead and move on. So we're testing the conjecture. Let's go down and see what our conjecture is. It says factoring can be used to create equivalent expressions. So that's what we're going to be testing. So test the conjecture number 1. It says write an expression that is equivalent to 12d plus 9 using factoring. So I'm actually going to give you guys a step-by-step way to be able to do this. So the first step is we're going to have to define the terms. Okay, so in this case we have two terms. We have 12d and we have 9. Okay, remember terms are separated by an addition sign or a subtraction sign. Okay? All right, step 2 is we're going to find the greatest common factor of our terms. So find the GCF. And so in this case, our terms are 12D and 9, so we need to find the greatest common factor of 12 and 9. Guys, remember T-charts? Okay, let's go ahead and do that. Let's build a T-chart for 12 and a T-chart for 9. Okay, for 12 we have 1 times 12, 2 times 6, and 3 times 4. For 9 we have 1 times 9 and 3 times 3. The greatest common factor on both lists is 3. Now what we need to do is we need to factor out our GCF. So remember, that means we're going to divide by our GCF. Okay, so we know that we're going to be writing these in multiples of 3 because that's what we're factoring out. Okay, so what times 3 gets us 12D? Well, 3 times 4 is 12, so 3 times 4D must be 12D. Okay, now we have to write 9 as a multiple of 3. Well, I know if I factor out 3, I multiply 3 times 3 to get 9. Okay, now all we have to do is rewrite our expression, but with 3, our GCF, factored out. So we're going to take the 3's out of the parentheses, and we're going to just put 1 to represent it. Then we're going to put inside parentheses what is left. So we have 4D, and then all the way at the beginning we had that plus sign, so I got to bring that plus sign down. And then we had left over in the second term, we had 3. Okay? So then step 4 was to rewrite expression. And finally, we can check with substitution. And we're going to say D will equal 2. So we have to test this original expression and then the final expression we got after factoring out 3. So I have a little space over here. I'm going to write it over here. So we have 12 times 2 plus 9. So 12 times 2 is 24 plus 9. 24 plus 9 gives me 33. Which is 2 plus 3. Is 11, and then we have to multiply by 3, giving us an answer of 33. Our answers are exactly the same. So here you have a step-by-step guide how you can write an expression by using factoring. Right, so let's move on to test the conjecture number 2. It says, which expressions are equivalent to 24p plus 32? Circle all that apply. So the first thing that we would have to do is define our terms. So we have 24p is one term, and then we have 32, a second term. Okay, step 2 is to find the greatest common factor of those numbers. So we're looking for the GCF of 24 and 32. So we'll create some T-charts over here. 24, 1 times 24, 2 times 12, 3 times 8, and 4 times 6. Okay, now let's do 32. 1 times 32, 2 times 16, 3, nope, we can't do 3. 4 times 8, can't do 5, can't do 6, can't do 7, can't do 8. Okay, so let's look for our greatest common factor. Our GCF here looks like it is 8. Okay, so let's look at our answer choices that we have over here. We have A, 2 times the sum of 12 plus 16. We have B, 8 times the sum of 3p plus 4. C, 12 times the sum of 2p plus 3. And D, 4 times the sum of 8 plus 6p. So we have to find all that are equivalent. So let's take a look at the number they factored out. If we can factor out a number of both 24 and 32, that means they have a common factor. So as long as these numbers appear on our list, we can check it out. Okay, so we have 2. 2 is paired with 12. Okay, cool, that could be right. And then 2 is paired with 16. So yeah, if I distributed the 2 to the 12, that would give us, let's see, come right over here. We would have 24. And then if I distributed the 2 to the 16, we would have 32. But if you notice, I have no variables. That's not equivalent. A variable is a number we don't know yet. So this is like taking out a whole number if we don't have it there. So A is incorrect. Let's check B. Well, 8 is a common factor. That was our GCF. Let's see, it was paired with 3 for 24. So 3 times 8 is 24p, cool. And then 3 times 4 gives us 32. Yeah, so that one worked out. So let's double check. So B, 8 times 3p, that would be 24p. Right, and then we do it again, plus 8 times 4, which is 32. And that matches. Okay, let's try C, 12. Well, if you notice, 12 is only a factor on 24's list. There's not a 12 on 32's list, so this one won't even work. Because 12 times 2 is 24p, so it got that correct, but then it says plus 12 times 3, and that's 36, not 32. Okay, so that one's incorrect. Now let's check letter D. We have 4 times the quantity of 8 plus 6p. So let's try D here. If I distribute that 4, I get 4 times 8 is 32. And if I distribute the 4 again to the second term, 4 times 6 is 24, and we have that p. And if you notice, this is just the same expression, but in the opposite order. So I could use the commutative property and switch these around, making it equivalent. So we have 2 answers here on Test the Conjecture, number 2, letter B and letter D. So, is our conjecture true? Factoring out can be used to create equivalent expressions? Absolutely, guys. Okay, and using equivalent expressions, you'll start to see that it's a lot easier. It's not as many steps as it would for an expression that hasn't been simplified.